Hi friends, here in this video we are going to see the condition required for maximum power transmitted in case of belt drives. In this I am going to derive a formula which will give us the formula for maximum power to be transmitted in case of belt drives, and for that purpose first I'll write the formula of power transmitted by belt drive. Now, here this is the formula for power transmitted by belt, that is P is equal to T1 minus T2 into V, where T1 is the tension in tight side, T2 is the tension in slack side, and V is the velocity of belt. Next, I'll write down therefore the belt tension ratio is given by T1 upon T2 is equal to e raised to mu theta, or I can say T2 is equal to T1 upon e raised to mu theta. Next, I'll put this value of T2 in equation number 1 of the power transmitted. Then I'll be taking T1 as common. After that, since this bracket contains mu, which is the coefficient of friction between the belt and the pulley, theta is the angle of contact, also called as angle of lap, and both are constant. So this complete bracket is constant, and that bracket I am going to replace it by a constant K. So here the formula will become power is T1 into K into velocity of belt, where I'll say let this bracket be called as K, a constant. Then after reaching up till this stage, we can also say that I'll be keeping this as the second equation, and now I'm going to find T1 by using the formula for maximum tension in belt. So therefore maximum tension in belt, that is T max is equal to tension in tight side plus Tc, which is called as the centrifugal tension in belt, and therefore T1 will be T max minus Tc, and therefore I can say T1 will be T max minus Tc is mv square. That is the formula of centrifugal tension. So now I'll be putting this value of T1, keeping this as equation third, putting this value in equation number second, replacing T1. So therefore power transmitted will become, next here we have K, I am going to multiply V inside, so this formula will become power is equal to T max into velocity minus mv cube K. Now I need to find the condition for maximum power transmitted. For that I'll be differentiating this equation of power with respect to the variable, and when we look into this formula, the variable is the velocity, because mass, the maximum tension, and K, these are all constants. So power, or we can say the maximum power, will only depend upon the velocity V. So the condition will be that for maximum power transmission, we are going to differentiate the equation of power with respect to velocity and equating it to 0. So therefore here we have this complete bracket, which is the variable, K is the constant. So I am using T max into V minus mv cube, differentiating with respect to velocity and equating it to 0. So the first term is T max into V. When I differentiate, I am going to get T max, and the differentiation of velocity is 1 minus m is a constant, V cube differentiation would be 3V square is equal to 0. So therefore the maximum tension will be this minus 3 mv square will go onto the right hand side, and that will become 3 mv square, and this is the maximum tension in the belt. All I can say that Tmax will be 3 mv square is nothing but centrifugal tension, so 3 times of centrifugal tension. And from this I can say that also when I keep velocity on one side, so this formula will become so for the maximum power to be transmitted by the belt, the velocity should be root of the maximum tension upon 3 times of mass of the belt. That is the condition for maximum power transmitted. Then after getting this value of V, that is the velocity, I can also go for finding the value of T1, that is tension in tight side. So I am going to write down that for maximum power transmission, we know that Tmax is 3 times of Tc, which is the centrifugal tension, and in equation number 3rd we have T1 in the form of Tmax, so I'll put the value here. So therefore T1 will be equal to, this is Tmax minus, it is mv square, which is centrifugal tension, and we know that for the maximum power transmitted condition, this centrifugal tension will be Tmax upon 3. So I am putting this value that mv square is nothing but centrifugal tension, and that is Tmax divided by 3. So in other words, T1 will be 2/3 of Tmax. That's the condition for maximum power transmission. And now finally, in the formula of power transmitted by belt, we can say that it was power is equal to T1 minus T2 into velocity of the belt. Then we had taken or put the value of T2 as T1 upon e raised to mu theta into the velocity of belt, and then this was reduced to T1 into bracket 1 minus 1 upon e raised to mu theta into the velocity of belt. Now for maximum power, I'll put the value of T1 and V in this equation, so I'll get the formula for maximum power transmitted. So here is the formula, that therefore maximum power transmitted by belt, that will be, I'll say P suffix maximum is equal to, instead of T1 I'll write down 2/3 of Tmax, instead of velocity V I'll write down root of Tmax upon 3m. So equation A gives the formula for maximum power transmitted by belt drive, and the conditions what we have achieved, that for maximum transmission of power, what are the requirements? The first requirement is that velocity should be root of Tmax by 3, this we have seen. Then the centrifugal tension is Tmax by 3, and also the maximum tension is 3 times the centrifugal tension, and finally the tension in tight side is 2/3 of the maximum tension. So these are the conclusions which we draw from this derivation for maximum power transmitted condition.